Hello everyone, I am Luciano Melo from Deep Learning Brazil Research Group, and today I will present our work Margin Offline Reinforcement Learning for Recommended System in Marketplaces. This work was done as a collaboration between Deep Learning Brazil and iFood Research. In the context of recommended system for marketplace, we observed a lack of resources to design, train, and evaluate agents that learn from interaction logs of these production systems, especially in the offline setting. For this matter, we present Margin, Marketplace Recommended System Gene, an open source framework to empower researchers and engineers to quickly build and evaluate reinforcement learning agents for recommendations in marketplaces. Margin addresses the whole development pipeline: data process, model design, simulation, offline training, and multi-sided evaluation, using metrics of recommendation, of policy estimation, and fairness. With Margin, we expect to bridge the gap between academic research and production systems, as well as to facilitate the design of new algorithms and applications. Margin models the marketplace as an MDP. The framework ingests a ground truth dataset sampled from a collection policy in the real marketplace to perform a counterfactual simulation, meaning how the policy in evaluation would perform if they had been recommending in the place of the collection policy, with the same perspective of the dynamics and reward distribution. MARS-Gym generates an OpenAI gene environment where the data drives the internal transitions resulted from the interaction within the recommender. The consumer of MARS-Gym must provide the ground truth dataset. First of all, the framework filters only successful interactions once they are the available source of the true reward distribution. Then the gene environment wraps the resultant data. We compose each environment step with one interaction. The provided observation contains the associated user and its metadata, as well as the contextual information from the log. As selected action, the agent should return the recommendation of one partner. We compute the reward by comparing the agent's selected action and the partner provided by the log. The agent receives a positive reward if they match. Therefore, the agent only discovers the targeted partner in the scenario of a successful recommendation. Otherwise, it should explore the action to build its knowledge. Finally, the interactions between the proposed agent and the environment generate new interaction logs. This simulated data trains the agent and also provides the cumulative reward curve as the first source of evaluation. During learning, we need to account for the bias from the collection policy. To address and reduce this bias problem, we need counterfactual estimators. Margin uses counterfactual risk minimization for off-policy learning. In our experimental results, we present our baseline agents evaluation and interpretation. We hope to illustrate the usage of the framework and to facilitate the work of new users. We used the Trivago marketplace dataset, where the partners are hotels. We performed the simulation of each proposed task until the convergence of many contextual benches to observe the cumulative mean reward. The performance drastically varies across tasks, which reinforces that there is no better strategy for all scenarios. Here, we evaluate rank and off-policy metrics for Chicago, USA task. The precision metrics highly correlates to the simulation results. We also observe a consistent drop from the precision to the off-policy metrics, suggesting that all methods naturally exploit the sampling bias. We also conducted an ablation study regarding CRM loss, and the results validate that this technique is essential to reduce the effect of sampling bias during training and therefore improve off-policy evaluation. We evaluate the Softmax Explorer bench on the Rexy City task in different perspectives of fairness. We selected a few sensitive attributes for all partners. In Figure A, we present features related to the type of accommodation. We observe that hotels receive a much better recommendation from the agent than the other types, such as hostels or apartments, suggesting disparate mistreatment, which is undesirable for the health of the marketplace. Figure B also presents disparate mistreatment for accommodations that are family-friendly or provide childcare. These are not only business features from partners but also user requirements. To conclude, in this work, we introduced Margin, a new open-source framework to model, train, and evaluate RL-based recommended systems for marketplace. We provided baseline implementations and analysis to serve as an introduction for the users. As future release of this framework, we plan to implement extensions for multi-objectivity and constraint optimization, that extends support for multiple stakeholders during learning. The source code is available at this address. Feel free to contribute. This is our team. Thanks.